The next section's about distance and midpoints. Okay, we're talking about lines and points here. There's two vocab terms from this section that could show up on the beginning of a chapter test. That's what a midpoint is and what a segment bisector is. Okay, a midpoint is the point on the segment that divides it into two congruent parts. It's exactly what we would think of a midpoint. It's literally in the middle of a line segment. The point directly in the middle. If it's a 10-foot long line segment, the midpoint would be at 5 feet. If it's a 50-foot line segment, the midpoint would be at 25 feet. Okay, it's the exact middle of a line segment. Okay? Exactly what we'd think of as a midpoint. Last is a segment bisector. This is what we're going to do with our construction today. Is any segment that intersects another segment at its midpoint. So one thing we're going to see a lot is this word bisector. Bisector means to cut in half. Bi means two, sector means segment. Okay, bisector, cut in two. So if we have a line, we have another line that crosses it, exactly its midpoint, cuts in half, that's what we call a segment bisector. Okay? A segment that cuts another segment at its midpoint. These are the two vocab terms we need to know from this section. So we're going to be talking about distance between points. How do we find how long it is to get from one point to another? And we have several different ways. Also, how do we find a midpoint? If I give you a line segment, and like if it's on a graph, how do you find where the exact middle is? Okay, we have a couple formulas for that. First, real simple, if you have a number line, let's say it looks like this. And I said, how far is it from point A to point B? What's the distance from point A to point B? What's the distance? 3, right? With me? 1, 2, 3. That's the distance from point A to point B. Okay. We find the distance. That's just counting over spaces, right? If we want to, we can subtract the distance. Remember, distance is always positive. Even if I said from B to A, it's still 3. Distance is always positive. Okay. If we want to, we can subtract those two numbers and take their absolute value. If we took -2 minus 1 and took the absolute value of that, -2 minus 1 is -3. And remember, absolute value always makes things positive, so that would be 3. Okay. You can just subtract the difference and find out how long it's from one point to another. Okay. Or if it's this small, you can just count the spaces. Okay. So that's how to find distance on a number line. What I really want to go over is how do we find distance on a graph. For example, a really simple one, if I said find the distance from A to B, okay, and I gave you these two here, well, you can just count over, right? 1, 2, 3, 4. It's 4 units from A to B, or vice versa from B to A, okay? Pretty simple when they're straight across from each other, or if they were straight up and down from one another. If I said from here to here, A to B, it'd be 1, 2, 3, 4 units that way too, okay? Distance is always positive. That's how to find distance if they're straight across from each other. The question is, now what if I give you one from here to here? So I'm going to know what is that distance. Okay. You can't just count units that way then, right? Because you don't really know where the next one starts and stops, because it's kind of in the middle. So I'm going to know how long is it from point A to point B. The way we do this is we have a formula to help us do this. First, let's identify the coordinates. What are the coordinates of point A here? 2, 2, right? 2 to the right, 2 up. That's at 2, 2. 2, 2. And what are the coordinates of point B? You might not be able to see that far. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. It's a 6, 4. Everybody agree with that? Okay. So I want to know how far is it from point 2, 2 to point 6, 4, how many units? And I can't just count because I don't know where the next unit starts and stops since it's at an angle, since it's diagonal. Okay. Different ways we can do this. The first is with this thing called a distance formula. This is what the distance formula is. It says the distance is equal to one big square root sign if you subtract the two x coordinates and square them, and add that to, you subtract the two y coordinates and square them. This is called the distance formula. Now remember, these things are called subscripts. These things at the bottom, they're not exponents. This just means the second x coordinate, the first x coordinate. The second y coordinate, the first y coordinate. Okay? This formula, and D stands for distance, helps us get from one point to another, tells us the distance. Okay? So we're going to use this formula on this problem. We'll come back to it in a second. I'll let people write that down and write it down. You will want to have this memorized. I know right now it looks really difficult and long, but all you're doing is subtracting the x-coordinate, squaring it, adding that to subtracting the y-coordinate, squaring it, and then taking the square root of the whole thing. Okay? This is called the distance formula. So let's look at this problem again. I'm going to write the distance formula up here for us. So I want to know, what is the distance from point A to B? It doesn't matter if I call this the first x and the first y, or this the first x and the first y. Doesn't matter. As long as if this is the first x, this has to be the first y. Or if this is the first x, this has to be the first y. Okay? The ones have to go together, the twos have to go together. So let's just call this the first x, the first y. Let's call this the second x, the second y. I could change it around just as easily. I would still get the same answer. Okay? So all I'm going to do here is plug these in to my formula. Distance equals square root. It says take the second x-coordinate, which what did I call the second x-coordinate? 6, minus the first x-coordinate, which was 2, squared, plus the second y-coordinate, which what did I call the second y-coordinate? 4, minus the first y-coordinate, which was 2, square that. Okay? And then I'm just going to start simplifying. I'll do the parentheses first. 6 minus 2, 4 squared, plus 4 minus 2, 2 squared. I can go ahead and square both of those things separately. D equals 4 times 4 is 16. 2 times 2 is 4. Okay. D equals, add those two things together, square root of 20. And if I punch that into my calculator, I can round and get an approximate decimal. So that's about 3.61, or 3 and 61/100ths. Okay? That is the approximate distance. Of course, we rounded it, so it's not exactly. Square root of 20 would be the exact. But this is the approximate distance from A to B, is about 3.61 units. If it was feet, I'd call it feet. If it was centimeters, I'd call it centimeters. But that's using a distance formula to find from here to here. Okay? 3.1 units. It doesn't matter which way I go. Remember, distance is always positive. Okay. So that's the distance formula. Questions with distance formula? All right. Like I said, there was another way we can do it instead of distance formula. And maybe you would like this way better or worse, I don't know. So let's say I have an XY coordinate plane, and I have 2 points. Call this one A. Let's call this one B. Let's do a different one. B. And I want to find the distance from A to B. We can identify the coordinates again. This is at 2, 1. This one is at -2, 1, 2, 3, 4. -2, 4. I want to find the distance from A to B. I could use the distance formula again. Okay? I could make this the first x, the first y, this the second x, the second y, plug them in, evaluate. That's a perfectly good way to do it. Another way I could do that, though, is I could make this line the hypotenuse of a right triangle. Remember the hypotenuse? Means the longest side. It's going to be the side opposite the 90-degree angle. So if I just made two new sides like this and made that a right triangle, okay, I could find the distance of these two red sides of the right triangle because they're just straight lines across, right? This one looks like it's 1, 2, 3. This is 4 units, the bottom one. And this one is 1, 2, 3 units. With me there? I'm still trying to find that piece. But I have two sides of a right triangle. All right, with me so far? So there's a theorem called Pythagorean theorem that says if you take one of the legs squared, the legs are the sides that make up the 90-degree angle. If you take one of the legs squared plus the other leg squared, it's equal to the hypotenuse, which I'll call it x squared. This is the Pythagorean theorem. If you take one of the legs squared plus another leg squared, it equals the longest side, or the hypotenuse, the side opposite the 90-degree angle squared. And maybe this is easier for you than the distance formula. 3 squared is 9. 4 squared is 16. 9 plus 16 is 25. So I have 25 equals x squared. But I don't want to know what x is. I don't want to know what x squared is. I want to know what x is. So what's the opposite of a power of 2? How do I get rid of a power of 2? Square root. If you square root it, those two things will cancel. You square root here. We only care about the positive number, so square root of 25 is 5. So that means this piece is 5 units. Yes, we'll get to that later chapter, but it is. Let's have you try one, and then we'll check our answer together. Okay? I want to know, find the distance, so just on a scratch sheet of paper somewhere. And really, you don't even need to plot these points. You don't even need to graph them. Okay? Unless you're going to use Pythagorean theorem, it'd be a little bit easier. Distance formula, you don't need to graph them. Find the distance between -1, -3, and 4, 0. So try that. Let's do this each way. So let's say you're going to use a distance formula first. You're not going to graph it. You're just going to plug in the points. So it doesn't matter, but since this one came first, I'm going to call this the first x, the first y. I'm going to call this the second x, the second y. I could do it the other way around. If you did it the other way around, that's fine. You're going to get the same answer. Okay? So I'm going to plug these in my formula. I'm going to take the second x value, which was 4, minus the first x value. So this might be where one common mistake came in. It's minus the negative, which when you have back-to-back negatives, it becomes a plus, right? Okay? Plus the second y coordinate minus the first y coordinate. Again, I have back-to-back negatives. That becomes a plus. Okay? Keep simplifying. Inside the parentheses, 4 plus 1, I have 5 squared. Here I have 3 squared. 5 squared is 25. 3 squared is 9. I add those two things together, and I get the square root of 34. Okay. That's the exact answer. If you want to approximate it, so you're trying to find like distance, you want to know how many miles, feet, inches. If you punch in square root of 34 on your calculator, 5.8309. All right, so let's just approximate to about 5.83. So that's the distance between these 2 points. Okay. 5.83. Let's see if you graphed it, what it would look like. So we know the answer is about 5.83. We should be able to get the same thing if we graphed it. So y-axis, x-axis, 4, 0, and -1, -3. I'm going to find the distance between those 2 points. So I need to draw a right triangle between those 2 points. I can either draw it down and over, or I could draw it over and down, either way. I'll change color here. So let's say I went this way. Down and over. There's my right angle. So let's count the units here. 1, 2, 3 units. Across here, 1, 2, 3, 4, 5 units. If you went the other way, it'd be 5 over, 3 down. Okay. Again, you're trying to find this piece. So let's say we call that x. Okay. I'm going to use Pythagorean theorem, so I'm going to take one leg squared plus another leg squared equals the longest side with the hypotenuse squared. That's 9 plus 25 equals x squared. That's 34 equals x squared. Square root both sides to get rid of the squared. And I get square root of 34 equals x, which we found that approximation just a minute ago. Okay. Yeah, that's fine. Pretty straightforward here. I want to know where's the midpoint between on this segment. Where's the exact middle on this segment? Okay.
1.
So you know the whole thing is 1, 2, 3, 4, 5, 6 units, right? So that means the midpoint's going to be 3 over. Right? 1, 2, 3. It's going to be at 1. Here's the midpoint. Okay. That would be the exact middle of these two lines. My drawing's not exactly to scale, so that's why it doesn't look like it. Okay. But let's say it was a really long number line and you didn't want to count over. Or let's say it was like this. Instead of being even, what if I said find the exact midpoint of here and here? Okay. Now I moved it over 1. It's 1, 2, 3, 4, 5 units. I want to know where's the exact middle of this one. Okay. All you're doing is you're just cutting it in half, right? You're going to take, it's 5 units long, you're going to cut it in half. 2.5, right? 1, 2, 3, 4, 5 units long. So I need to go over 1, 2.5 units. And it's there. Okay? But that's the distance of the midpoints. If you just take the average of these two numbers, where it's at, okay, you can find out where the midpoint is. How do you find average? You add the two numbers and divide by how many there are. Two numbers, right? So if you take -2 plus 3 and divide by 2, -2 plus 3 is 1. 1/2, that's where the midpoint is. Okay? So it's pretty easy on a number line. You just find the average between those two numbers. So if I gave you a really big number line, and let's say down here was -84, and you had all these points in here, and up here was 20. I want to know, where's the midpoint going to fall? At what place is the midpoint going to fall? Okay. Don't want to count that one. Don't want to count that one because it's a lot longer, right? So we're just going to find the average between these two numbers. How do you find average? You add the two numbers, you divide them by 2. -84 plus 20, divide by 2. If you're in debt $84, you add 20, you're in debt $64. You divide that by 2, -32 is going to be the exact midpoint between those two coordinates. Okay? Between that number line. Pretty easy with the number line, right? Nothing too difficult there. So then when you add a coordinate plane to it, when you add graphing, if I asked you to find the distance between those points, you could do it, right? You would use either the distance formula or you would make it a triangle, okay? But now I want to know not where the distance, I want to know where's the coordinate of the midpoint. It's going to be somewhere in that range, right? It might be like at 1, 1, 2, 3. It looks like it could be there, but it might be at 1, 3.1. Or it might be at 0.93. Okay? I want to know where's the exact midpoint between these two coordinates. Okay? And we have something called the midpoint formula to do that. The midpoint formula looks really complicated, but it's not. This is the midpoint formula. Okay? This is how you find the coordinates of a midpoint. All you do is you take the average of the x's, you add the two x coordinates, divide by 2. That's your new x coordinate. And you add the two y coordinates, divide by 2. You find the average of the y's, and that's your new y coordinate. Okay? This is called the midpoint formula. Okay? The midpoint formula. How do you find the midpoint between two things on a graph? You average the x's, you average the y's. That's your new xy coordinate for the exact midpoint. Okay? So let's go back to this problem. Let's find the coordinates. Oh, sorry, I'll go back. So back to this problem. This is at -2, 2, right? This is at 1, 2, 3, 4. 1, 2, 3, 4. This is at 4, 4. So I want to know where's the exact midpoint between these two segments. Okay? The midpoint formula says average the x's, average the y's, and that's the midpoint. So let's call this x1, y1 again. Let's call this x2, y2 again. Doesn't matter. You could switch them just like the distance formula. So when we average the x's, we're going to take x1 plus x2, divide that by 2. We're going to take y1 plus y2, divide that by 2. -2 plus 4 is 2. 2 divided by 2 is 1. 2 plus 6 is 8. 8 divided by 2 is 4. So the exact midpoint between these two coordinates is at 1, 4. My drawing's not drawn to scale because my axes are a little off, but that would be the exact midpoint. Okay. Oh, sorry, no, I put a 6 here. That's why. See that? See a mistake? I'm sorry. I put a 6 instead of a 4. Y2 is 4, right? I was going to say I looked a little more off than it usually is. Sorry, that should be a 4 because 2 plus 4 is then 6. 6 divided by 2 is 3. So the exact midpoint is at 1, 3. That looks like it could be the midpoint. My midpoint's at 1, 3. Okay. So, try, without graphing it, you could graph it, but you don't really need to. Find the midpoint between 512 and -4, 8. I want to know where's the exact midpoint between these two coordinates. So I'll give you a minute to try that. Compare your answer with this. So we want to find the exact middle between these. Let's just call this the first x, the first y, since they come first. Second x, the second y. So if I take it says take the first x plus the second x, divide that by 2, that's the x coordinate. Take the first y plus the second y, divide that by 2, that's the y coordinate. 4 plus negative 4 is 1, so the x coordinate's 1/2. I can just leave it as 1/2 because it's 1 over 2. 12 plus 8 is 20. 20 divided by 2 is 10. So 1/2, 10 would be the exact midpoint between these 2 points. Okay? I would go to 1/2 on the x-axis, I'd go to 10 on the y-axis, there would be the exact middle. Okay, let's look at the difference of this problem. This is the last one I want to go over here. I want to find the coordinates of a point G, but now I give you the midpoint, I want you to find the missing coordinate. Okay? So let's look what it looks like on a graph. So at negative 5, 10, my graph's not going to go that far. But if I go to negative 5, 10, let's just, we'll just leave it. If I go to negative 5, 10, that's the midpoint, and E is one of the endpoints. I want to know what's the other endpoint, G. So now instead of finding the midpoint, I give you the midpoint, I want you to find the other endpoint. That makes sense? The formula is still the same, but just what you plug in is different. Remember, the formula says if you take the first x plus the second x, divide that by 2, that gives you the midpoint. Let's call that the third x. Okay? Let's call the third x the midpoint. And the same thing with the y. If you take the first y, the first endpoint plus the second endpoint, divide that by 2, that gives you the midpoint. Okay? So now instead of giving you both of these coordinates, I only gave you one of these, and I gave you the midpoint. Right? So let's just plug this in where we need to. This, where would I plug in P? X1, X2, or X3? I'd plug it in at X3 because I call that the midpoint, right? So let's call this X3, Y3. What about this one? It's an endpoint, so it doesn't matter. It could go X1, X2, or sorry, it could go X1, Y1, or it could go X2, Y2. It doesn't matter because the endpoints, one of them is the first coordinate, one's the second. So let's just call this X2, Y2. I could call it X1, Y1, but it doesn't matter. So if we plug those in, I'm going to solve for X1 plus X2 is negative 8 divided by 2. That should equal negative 5. That's my endpoint. That's my midpoint. Okay? And then Y1, I don't have it. I do have Y2. That's the other endpoint. When I divide that by 2, that should be equal to 10. Okay? So I still use the same formula, but I'm missing the endpoint. I'm missing X1, Y1 instead of the midpoint. I could have plugged in for X2, Y2. So the question is, how do we solve these then? Well, first we have to get rid of all of this division. So how do you get rid of all of this division by 2? Multiply by 2. So you multiply all of this by 2. That means those are going to cancel. Those are going to go away. You get rid of the division. You multiply all of this by 2. I'm going to go ahead and erase this right here. So I'm going to get X1 plus negative 8 equals negative 10. And here I'm going to do the same thing. I'm going to multiply by 2. That's going to get rid of that division by 2, which I do the same thing the other side. I get Y1 plus 6 equals 20. So now I just solved both of these for the endpoint. This is plus and negative. Let's change that to a minus to make it easier because plus and negative is the same thing as subtracting. To solve for X1, I just move the negative 8 to the other side. I do that by adding. X1 equals negative 2. That's the x coordinate of one endpoint. Subtract 6, subtract 6. Y1 equals 14. So the coordinates of the other endpoint are at negative 2, 14 is where G would be. Okay. I used the same formula, but I had the midpoint instead of. That's really the hardest type of example they can give you.